Amines and Amides. Now, this is not a practical, the content I'm going to go through in today's video. It's not a mechanism. It's not past paper questions. It's just content. So I'm thinking now of creating a playlist just on content, and this might be the first one. So probably is going to be. So amines is when one or more of the hydrogens in ammonia is replaced by organic group. One or more of hydrogens in ammonia is replaced with an organic group. Amines are organic derivatives of ammonia. Primary amine, one hydrogen is replaced with an organic group. Secondary amine, two hydrogens are replaced with an organic group. Tertiary amine, three hydrogens are replaced with an organic group. And then for the final one, lone pair of electrons on a nitrogen atom in a tertiary amine bond with the fourth organic group, and this is called a quaternary ammonium ion. When the lone pair of electrons of nitrogen in tertiary amine bond with the fourth organic group, quaternary ammonium ion. Why are quaternary ammonium salts with one long hydrocarbon chain used as cationic surfactants? Well, what happens is basically the hydrocarbon tail binds to the non-polar substances like grease and and the cationic head dissolves in water, so therefore it's useful for fabric cleaners / hair products. The positively charged part binds to negatively charged surfaces. So the ammonium ion, the positively charged part, binds to negatively charged surfaces, hair and fiber, removing static. Therefore, it's used in fabric conditioners. Definition of amines. Well, they act as weak bases, accepting protons, have a lone pair of electrons on a nitrogen atom, and they form coordinate bonds with a H+ ion. Act as weak bases, accepting protons, lone pair of electrons on a nitrogen atom, form coordinate bonds with H+ ions. Why does strength of base depend on availability of nitrogen's lone pair of electrons? Is more available the lone pair, the more likely amines to accept a proton, therefore stronger base. And it makes sense. More available lone pair, more likely amine to accept a proton, therefore stronger base. A lone pair of electrons is more available if it's a higher electron density. Now, this is really key. So how do you know if it's a more available lone pair? Well, you know a lone pair of electrons is more available, higher electron density. Why are primary aliphatic amines stronger bases than ammonia and aromatic amines? Well, primary aliphatic amines, well, the alkyl groups push electrons on attached groups, so the electron density of the nitrogen increases, therefore lone pair is more available, therefore stronger base. Benzene ring, well, the benzene ring in aromatic amines, benzene ring draws electrons to itself, and the nitrogen lone pair is partially delocalized onto the ring. Therefore, the electron density on nitrogen doesn't increase, it decreases. Therefore, the lone pair is less available, therefore a weaker base. Primary aromatic amines, ammonia, and primary aliphatic amines. And you go here, stronger the base. And the strongest one is obviously in this case primary aliphatic amines. The stronger bases then ammonia and aromatic amines.